Okay, so let's talk about AGI. What if the key to making a true artificial intelligence wasn't about giving it some super complex goal, but about taking goals away completely? I mean, think about it. Almost all AI research today, from the large language models we use to self-driving cars, it's all built on optimizing for something. But I stumbled across this wild paper online that just throws that entire idea right out the window. So today, we're going to break it down.
Right, so let's just dive in. The author kicks things off with this really powerful question that just flips the whole script on its head. Instead of programming an AI to win a game, or maximize a company's profit, or even just predict the next word in a sentence, what if we just didn't? What if having a specific, predefined goal is actually a limitation? Kind of like a set of blinders for a truly general intelligence.
And to make that point, the author immediately hits you with this quote. It goes right after the most common assumption about intelligence, that it's all about survival. I mean, if survival was really our #1 primary drive, the author argues that the safest thing you could possibly do is just lock yourself away from any and all harm. But we don't do that, do we? We seek out experiences, we connect with people, we create things. So if it's not survival, what is the real driving force? To answer that, the author first tries to figure out what the output of intelligence even is. They basically say that things like survival or passing on your genes, those aren't the main objective. They're more like side quests that you do in service of a much bigger, more fundamental purpose.
So here's their starting point, and it's actually super simple. Just look around the world. What's the real difference between, say, a barren rock and a bustling city? It's not just that one is more complex, it's the sheer volume of, well, stuff. You've got art, music, language, technology, all these ideas. Intelligence, the paper argues, is basically a machine for creating more stuff. But, and this is key, not just any old stuff.
So, if intelligence isn't just about creating random junk, what is it about? This is where the core idea comes in. The author proposes that all intelligence is driven by this one simple, innate desire to maximize something they call higher-order novelty.
And to really get this, the author gives this fantastic analogy. Think about watching the waves on a beach. Every single wave is technically unique, right? It's technically novel. But after a while, you get bored. It's just simple novelty. Now compare that to something like a company logo. It's a simple image, but it can set off this whole cascade of thoughts, memories, feelings, and associations in your head. That is higher order novelty. It's newness that has some real conceptual depth to it.
So here's the crucial point, the main definition. Higher order novelty is the stuff that really captures our attention. It's that feeling you get when you see something truly interesting, or hear a new song that just clicks, or you finally grasp a new idea. And for that brief moment, you just stop. You're not trying to do anything, you're just absorbing this new, interesting thing. The theory is that this drive to find and create that feeling is the real engine of all intelligent action.
Okay, so how would an AI actually do this? How do you turn that feeling of, that's interesting, into an actual mechanism for learning and getting smarter? Well, the paper proposes a really simple but kind of elegant feedback loop.
This right here is the engine of the whole system. The easiest way to think about it is like boredom versus curiosity. When the environment is static and predictable, when there's a lack of novelty, the system gets bored, and it starts to act, randomly at first, just to shake things up. But when one of those random actions produces something interesting, something with that higher order novelty, it relaxes and just pays attention, soaking up that new pattern.
In fact, the paper boils this entire process down to a dead simple 4-step algorithm. It's basically trial and error, but supercharged with memory and association. Step 1, just keep doing different things. Step 2, when you do something that creates a novelty, stop and pay attention. Step 3, remember what you just did. And Step 4, associate that action with that interesting outcome. Over time, this makes you way more efficient at creating novelty in the future.
Okay, so that's the theory. This constant search for novelty is what drives the system to learn. But what about the actual blueprint? The nuts and bolts of how you'd build this thing? Well, this is where the paper makes some of its absolute boldest claims.
So the blueprint is, in principle, really simple. You start with a massive spiking neural network, or SNN. Now, unlike the neural nets we usually talk about, SNNs work a lot more like our own brains, sending these little discrete signals or spikes only when they need to. It's way more biologically realistic, and we're talking trillions of neurons, so on the scale of a human brain. Then you just randomly connect its inputs and outputs. And here's the real kicker, there is no pre-programmed objective function. The only learning rule is Hebbian learning, that classic idea that neurons that fire together, wire together. That's it. No complicated backpropagation, no reward function, just pure, raw, unsupervised association.
And from this, shockingly simple setup, the author claims that everything else will just emerge. The system's drive to maximize novelty will, over time, lead it to learn to walk, to talk, to reason, and yes, even to learn how to make an excellent mutton biryani, just for the sake of creating a new and interesting experience for itself.
I mean, it's an incredible idea, right? It feels so philosophically elegant. But, and this is a big but, for now, it's just an idea. It only exists on paper. And when you make claims this huge, you are absolutely going to get some strong reactions.
And look, the theory has for sure found its fans. The author's website shows emails from supporters, like this one. It's from a reader who, after reading the paper for the third time, became totally convinced that this is, and I'm quoting here, the only way to AGI. They see this beautiful simplicity in the idea that just really resonates with them.
But then, of course, you have the other side of the coin. You have the skeptics. And this comment from the author's blog sums up their primary criticism perfectly. In the world of tech and AI, ideas are great, they're powerful, but proof is in the execution. And without a working prototype, well, it's just a theory. So why isn't there a demo? This is the twist. The author answers this question directly at the end of the paper, with just incredible honesty. They say they're an ideas person, not a developer. They just can't code, and they haven't had the money or the resources to build it. So they're putting the idea out into the world, hoping that someone else will pick it up and run with it.
And that leaves us with a really fascinating question to think about, doesn't it? On one hand, you have this compelling, elegant theory that challenges the very core assumptions we have about intelligence. But on the other hand, there's zero proof that it actually works. So what do you think is more valuable in this whole quest for AGI? A groundbreaking theory all on its own, or the code that actually brings an idea, any idea, to life?